Section 3.4, density. Here's the objectives. Calculate the density of a material from experimental data and be able to describe how density varies with temperature. So those two things, make sure you understand that part of it when we get out of here. And let's take a look at some different things, all of which are 10 grams. So if we have 10 grams of lithium, you know, you've got this nice square. You got 10 grams of water, it looks like a little bit smaller. And you got 10 grams of lead, which is a lot smaller. And so you have the same mass of all of those, but you have different volumes for each one. And density is the relationship between mass and volume. So the density of lithium is 0.53. So it's, you know, it's not very dense. So, you know, if you were to lift it up, it would not feel very heavy for its size. Water, you're all pretty familiar with that. And then lead is very dense, so it feels pretty heavy for its size. So if we want to determine the density, it's going to be the ratio of mass to volume, and so we're just talking about mass divided by volume. Just, you know, think of density equals m over v. Usually we express density in terms of grams per cubic centimeter, and density is one of those things that is an intensive property. In other words, it doesn't matter how much of a substance I have. If I have just a little bit or a whole bunch, it's going to be exactly the same density for all those. Here's just a chart with some different densities so you get an idea. You can see gold very, very dense at 19.3. That's way up there compared to all the other ones. And, you know, I mean, water is kind of our standard at 1, and you've got some different things in there that you can look at. Aluminum, 2.7, sugar, 1.59. You know, we get into the gases, and they're very, very light. If you look, in fact, if you look at the gases on the right, it's no longer grams per cubic centimeter because that would give you a very small number, so they write it in grams per liter, you know, or grams per 1,000 cubic centimeters if we want to kind of keep it the same. So if you divided those numbers by 1,000, then it would be grams per cubic centimeter. One thing to be aware of is that density changes if the temperature changes, because most things, as the temperature increases, the volume increases. Therefore, if the volume, what you're dividing by, increases, the density becomes smaller. Let's take a look at a sample here. It says a copper penny has a mass of 3.1 grams and a volume of 0.35 cubic centimeters. What is the density? Well, simply put your things into the formula. We've got the density formula. Density equals mass over volume. Put your numbers in. So we've got 3.1 grams, 0.35 cubic centimeters. If you divide that out, you end up with 8.8571. Too many significant digits there. Remember, this one has 2, this one has 2. My answer can only have 2. So we would round it off to 8.9 grams per cubic centimeter. Okay, you guys try 46, 47. Stop the video and do those two problems. When you're done, turn it back on and I'll go over those with you. Alright, so the first one, student finds a shiny piece of metal, thinks it's aluminum, determines that the metal has a volume of 245 cubic centimeters and a mass of 612 grams. Well, let's figure out the density. Mass divided by volume, 612 grams divided by 245 cubic centimeters. If we divide that out, it comes out to be 2.50 grams per cubic centimeter. Run out of room. Is it aluminum? Well, the only way that you would know is you need to know what the density of aluminum was. That's back a couple of slides. The density of aluminum is 2.70. So no, not aluminum. On the next one, bar of silver has a mass of 68 grams, a volume of 6.48. What's the density? Well, 68.0 grams divided by 6.48 cubic centimeters. And what we end up with is 10.5 grams per cubic centimeter. All right, let's go on. Clear that. Next problem. What is the volume of a pure silver coin that has a mass of something there? Let's move that out of the way. Mass of 14 grams. The density of silver is 10.5 grams per cubic centimeter. Now what we're trying to find is volume, and these always get to be a little bit more difficult. We're trying to find, we have this formula, density equals mass divided by volume, and when you're solving for volume, those are always kind of the more difficult ones. If we want to go through this algebraically, in order to solve for volume, let's get volume on the top, and I'm going to multiply both sides times V, and then I'm going to divide both sides by D, and I end up with volume equals mass divided by density. So that's my final equation that I'm going to use, given the fact that I have the mass and the density. So the mass, 14 grams, the density, 10.5 grams per cubic centimeter. Multiply that out, and I end up with 1.3 cubic centimeters of silver. All right, so you try problem 48 and 49. Once again, stop the video, work those two problems, and I'll come back and go over them with you. All right, so in the first one, it wants to know, it says use dimensional analysis and the given densities to make the following conversions. 14.8 grams of boron to cubic centimeters of boron. The density of boron is 2.34 grams per cubic centimeter. So here's what they're trying to say, and I'm going to show you this. And this wasn't exactly the way that I did the last problem, but I'm not maybe a big fan of dimensional analysis on this type of problem, but you can certainly use it all the time. I mean, it's not wrong. I just think sometimes it makes it a little bit more difficult to think of. All right, so what it says is you're trying to find the cubic centimeters. So we want to know how many cubic centimeters given 14.8 grams. And what we also know is the density, and here's what you could kind of think of it as this. You've got 2.34 grams per 1 cubic centimeter. So that's what I'm going to do to get rid of that. But if you want to calculate that out, what we've got to do is say, well, that's 1 cubic centimeter over 2.34 grams. And I mean, they give it to you as 2.34 grams per cubic centimeter and 4. That's a 4. You have to kind of flip the label a little bit, and I find that kind of confusing. I think it's almost easier to do what I did in the last problem, where you solve for V and then plug it in. But you can do it either way. You're still going to do the exact same math. So you're going to take 14.8 divided by 2.34, and you're going to end up with 6.32 cubic centimeters for this one. If you do the same thing for B, you're going to take 4.62 grams, 1 cubic centimeter over 13.5 grams. You're going to end up with an answer of 0.342 cubic centimeters. And then they ask you to do it this way. That's the way we did it before. So you should get the same answers. There you have it.